What in the world is this? Am I right? This is some ASCII viewer of I made of a Perlin noise generator on the BQN libs repo. I'll link that in the comments. But look at this. Okay, this is pretty cool. I can go left and right. So here, if I tell L and H for left and right here, I guess for the enter to hold it and repeat this. Isn't that cool? But wait, check this out. Okay, we gotta zoom in a little bit. Look at this. Is that insane? You just do stuff, and I can reset with R, or I can do LLL zoom, and then it'll all do it in order here. Not too big a deal. It's pretty cool looking, I gotta say. Oh, then I can also zoom out with X. X a million times. It'll zoom out a lot. It'll crash if I go too far. But isn't that cool? Okay, anyway, uh, I'm not gonna go into the actual source of the Perlin noise because that's online already. But I'm just gonna talk about what I did to get this viewer going, which is not that crazy. It's like 10 lines or something. Check it out. And let's make this a little more reasonable because I'm not I am split screening. So let's see if this works. Cool, and we're still partying. Okay, cool. All right. So again, the Perlin noise thing, if this works well, is right here. This is what's online. I'm not gonna explain any of this stuff because I don't understand it, frankly. But this is generates your state, and it runs through the state and makes a noise. Pretty straightforward, sort of. But this generates returns a namespace, and the namespace goes here. And so, okay, a little bit. You get the generate function, and then sorry, this is the generate function. I think it's the generations function. I don't know, but it gets called here, and it actually gets put into the cache if it doesn't already exist with this number. So you say you generate the 10th generation or something. I don't know if that's actually the number, but let's say the 10th generation. Then it says if the length of GC is less or equal to this. I'm getting sidetracked. The point is, it's pretty cool. Okay, let's go back to where we were. So the viewer, okay. You generate the state. I made a change to it to just support taking in my existing RNG. Let's see if I can show it here. It's the exact same one as this. You'll notice make data, except they use the standard library one, I guess, and that's what it do. But they make it so it's new every frame, whereas I just made it so it persists across. So I see it with a random value, but otherwise it's exactly the same. Save for the fact that they added 1 onto this. I'm not sure why. It probably has a good reason. I just never fell into the. I probably never just experienced the bug yet. So anyway, back to the code. So this is the state. So what the zoom is, what the offset is, so left and right, and then whether I should continue or not. Because it's basically running the render function in a loop based on whether the output of the get line function, where is it? Here we go. We're jumping around. Returns a Q or not. So now at the bottom, okay? We create our state that is persistent and it mutates actually. Then we have our chars. This is like at a 0.0 we get the blank character, and all the way up to 1.0 we get the heavier characters. This could be like anything you want, but I couldn't. The more characters you use, the more definition you have. So if I just nuke a bunch of them, it'll kind of look okay still, but it won't be as like the details is lost. So I just added a bunch of characters that I think is pretty cool. Okay, so here I generate a 30 by 60. Like 30 rows of 60 characters each columns. Then I divide it by zoom to get the actual zoom. Otherwise, it just won't zoom in at all. Then this is the first time I did this, where it's from the bottom numbers here. Can I actually show what this does? It just applies the offset plus at every rank because there's like a nest. Oh, okay, I can actually show you. We'll do it live. Here, check it out. So these are the numbers. This is the numbers, right? So we have. Actually, okay. So we have the numbers from 0 to 0 to 30, 60, I think I did. Then we divide them by zoom. So now they're all divided by the total zoom of 15. Then from there, we add 1. We add the offset to everyone. So the offset is 1 and 0. So this will become 1 and 0, and this will become 2.9 and 0, if I'm correct. 2.9 and 0. Excellent. We're partying. Then we reshape it all into a list. Then we group it up again. So can I actually demo this? Again, I don't want to get bogged down in details, but here we are. So this is a 2-table list, I guess, a 2D, and then for some reason it's got to be put in a second list again, so you can see at the very top. I'm not going to scroll up a million times, but it's there. Okay, then it generates the data. The data is just that looks not what I expected, but just more noise. Just more noise. Let's say same data. Actually, I can make it RNG every time. We're easy to follow here. Perlin. Okay, good. If I resave it every time, it'll just make much random data. We're partying. We're easily to follow. So we have our noise. Okay. Now we just clear the terminal using tput, which is like your terminal tput. It tells you calls and lines, whatever. Tells you the size of your terminal, so you can just like, tput clear to get the actual clear screen. No big deal. Dump a new line, blank screen. Then the fun part, finally, the actual rendering of the noise, where we enlist it. I can't remember why. Who knows? Then we just add up all the numbers. What am I even doing here, buddy? What am I doing? Oh, right. So because noise, like I said, it gives you the two-dimensional. Can I go back up without? Perfect. So because our noise here is our list of two-dimensional noise, that's not actually enough to render because you need to figure out which one of these two coordinates, like the x and y's, I guess, for everyone to display. But that's not good enough because you could only ever use one, but the number barely changes. So you get the actual magnitude of each of these guys. So that's what I did here. But you square it and then you sum it of both, like a squared, yeah, a squared plus b squared, square rooted. I guess I don't know. Not a mathematician. Point is, it works sort of. And then here, all we're doing is we're getting the length right. Okay, so because we have this number now that is scaled to the it's like the magnitude. It should be from 1 to 0, right? Isn't that right? We'll find out. So you can see if I get rid of this, you have our numbers here. It's never goes above 1. So we use that now to grade into this. And grade is like a bucket scenario where you have how do I put this? If you have here, actually, this is kind of important because it took me a while to get. Can I do it like this? Hold on. We'll say I don't remember if it's like this or not. Let's ABC. No, this won't work, will it? 0, 10, and 25. We grade it. We grade it. We'll find it. We'll find the grade character. Come on. It's not hard to find. There we go. Program's easy. So this is 1. So this should go in the first bucket if I'm doing this right. Okay. And if I put the second one, if I add this new number, this will go to the third bucket because it's after 10. Second bucket, the 0th. Right? So, and again, hopefully 0 will be the first bucket. Because there's actually a bucket like before here. Can I demonstrate this? How do I the docs use a pinball scoreboard, I think. But the point is, so 1 here goes between here and here. 12 goes between here and here. 0 goes here or here, I guess. And if I go -1, -10 doesn't matter. It'll go 0, so it'll go before the 0th element. And then if I go again, oops, if I go, we're frozen. If I go a million, it'll go after the last element, so it'll go here. Okay, that's grade up. And grade down is the same thing, but just the opposite direction. I'm not going to worry about finding the character here, but here, if you want to know what the character is, it's /Shift T, and it's Shift V for the other one. Perfect. So we're here. We're saying get length of characters, so the count of this thing, times the actual value that's coming in. So if you have 0.3 or whatever, it'll take the length of this times 0.3, and that'll get you the 0.3 thing, I guess. And then you want to figure out which. I'm just saying things. You have to figure out where it lands in the sorting. So the length of chars -1, and then the range. Actually, that's a good question. Now that I'm thinking about this, can I get rid of that range scenario? Can I just do this? Will it work? Probably not, right? No, okay. Not even close. Apologize for that. So we have grading where the light here, you know what? Let's visualize this for fun here. Go 10 by 10. Okay, a tiny little guy. Okay? Do I have an exit somewhere? Oh, I'm BQN watch. Okay, here. Hold on. Sorry, that's the watch exec. Here we go. Zooming out, zooming in. Easy. Okay, so we want to just see, like, for example, what our number is here. We have a bunch of numbers that are up to the length of this. And then we want to figure out where they land, yeah. I guess grading supports floats. You know what? Don't worry about it. The point is, we have our numbers here, and I'll just take 10 of them. 10 of these numbers, and then that goes into the length of these guys. So we have our left argument here. Actually, I'll just do this again. That callback is really nice. So we have here the length of characters minus 1. So then each one of like at 14.0 goes between here, and so that gives you the 14th character basically. That's all, really all it is. Is there an easier way to explain this? No, but probably. But let's just go for here for now. That this is working enough. So we have our characters that we've chosen. Okay, then we have to resize them, regroup the output because it's a linear group of characters right now at this point. Sorry, the index of the characters, I should say, right? Because we know which character we want to pick, and we still have to pull them out, which we can do here. I can stop exiting probably and just show this at some point, but watch again. So we have our characters. I can go back here to see what the characters were, maybe. No. But with this, you see that it's a linear list. It's a list of things. And we want to reshape it. So we got to actually reshape it to the length of our data. And data was just the 10 by 10 grid at the start here. I can just regularly show this. Oh, I cleared it. Hold on. Sorry about that. See, so we have our list of 10 by 10, and then we use that again to get the shape of it, which is 10 by 10, which is exactly the same number. Oh, you know what? I hold on. I just also realized if I just remove this, because I don't use data again also, right? No, I don't. So I could just literally call this like if I do this, call this shape or something. Shape. Nice and long. Got this here. Hold on. We're learning as we go. Go to exit. Okay. Yeah, perfect, right? So now I can zoom in. I get rid of the watch. Zoom in, zoom in, zoom in. I also get rid of the clear apparently. But yeah, I think that's working. Neat. Okay. So now that we're there, right? We have our list to be reshaped. Yeah. All right. Whatever. Let's we're cool. We're partying. Okay. So now, once it's rendered, that's really the whole thing. The rest of it is just managing the output, like managing where it goes. So here, this is just the standard function. This is only available in CBQN. It's not available on BQN.js. So basically, the BQN pad, the official BQN REPL, and even the nice Mechanize site. There's 3 BQN REPLs online, 4 maybe, but the 3 that I know about don't support this, which is a shame. And then the ones that do don't support a custom RNG generator, so you can't use this online as far as I can tell. But so what we're doing here is we're getting the line, which is returning a string of the characters you punch. And all I'm doing here is because I don't want to have invalid strings. When you press enter, for some reason, it returns, well, not for some reason, for exactly the good reason, it returns you an empty string. So I just got to make sure that if the length of it equals 0, we want to just join it, input. Yeah, what? No, sorry. My goodness. I just say stuff. This is saying if it is empty, join input, which is the old input, which is from the last loop. I should have clarified. Otherwise, it'll just go. We're just waiting for some. It's lagging. No big deal. Give it a time. There's some problems with my computers. I can't actually copy and paste from here, so it's taking its time. Give it a minute. So while it's thinking, there you go. I think we're partying now. Perfect. So now the next thing is once we have our resp string, the like the response from the user, basically, I just parse it really. Like I just say, if you're equal to any of these characters, do that thing. So this bad boy here is, I think, classify or something. Let me see what it's called. Index of, even better, because do dyadic. But it's the index of. So if my response, let's just do it. Can I do this here? Come on. Go to the top of this file, paste it in, and we'll say H. Well, no, let's go Z. No, we'll do this so we don't have a problem. Bring back the watcher. Okay, so here's the index of this character is 4. Or if I do this, this is 0, right? And this tells me the index of it. And then I use that index with choose, which is kind of cool. This bad boy. Choose, which is basically based on the number you return from the left side of this function, I'll call a function for you. So it's like a conditional sort of, where the conditional or switch case is 1 through or 0 through whatever. So if the index is 0, it's H, which calls the H handler, which I've named H. And that, like all the other ones sort of, just do take offset, modify it, or under it, like, take the first element, then add the reciprocal of Z here, and I should say this also is equivalent. So from the take offset, take the 1th, so the second item, add 1 zoom to it. And I can't just do 1 actually, because it's got to be accounting for the zoom. If I just do 1 all the time, it'll like zoom like crazy if I'm not zoomed in. So check this out. Here, I'll demonstrate that because I think we're all wondering. I'll just put this back to something bigger so you can actually see maybe. Okay, and we'll go get rid of the watcher, and we'll get rid of the exit. Okay, so here if I zoom in a bit, and I press L with the zoom accounted for, it goes a little bit. But if I go H with a lot, it just jumps like crazy. That was a bit of a thing to figure out. But if I go back to H when it's zoomed out a little bit, it looks like normal because it's not considering the zoom. So we're still good. We're still not zoomed out enough, I guess. I actually just hit R. There you go. Because we're zoomed in by default by 15. Anyway, making some progress here. So we have our offsets. So remember that the way under works is kind of tricky, but it does this thing, then the thing on the right or left, then it undoes this. So it takes this element, then does this math on it, then puts that element back into the offset, which is pretty cool. Same thing for J and K, where it adds the instead of the X, it adds the Y, like for up and down, So H and L is left and right, and Z, J and K is up and down. Easy. Zoom is the same idea, where we just add one of the reciprocals to the offset, because if we don't account for the offset's position, when you zoom in, it won't center. It's a fun little fact here. So here I'll zoom in again. So I'm zooming in from the corner, but if I account for the position, it'll zoom in from the middle-ish. It breaks as you zoom in more, but watching zoom in is fun. So to me, that means there's some like offset or imperfection or something. But I think it's pretty cool. So anyway, we zoom in, and then X is zooming out. So it's just adding and subtracting the R. R is just resetting the state to the initial one up here, to this guy, back to defaults. Because that's what Z is doing, is zoom, and the offsets are the X and Y positions. And then N is just reassigning state to a new variable that is actually using random data. What is R? Oh, I see. Sorry. It's calling R first, which is reset. And then it's generating the noise data. And then we pass back the last character. And like I said before, that's when you press enter, you can do this input thing and just reapply the same thing. So if I press Z once, or Z, I can just hold enter, and it'll just re-hold the same character. And same with this. If I just do L once, same idea. And even if I do like zoom out, H, down, L, it'll just remember the L last. I can just keep moving left. Or right, I guess. This is another tricky one, where this is this uses the while function. So this guy, I can't inspect the docs, but it takes a condition, and it takes a function, or whatever on the condition, and the value. So it runs this function on this value. Then if that passes, if that's yes, it runs this guy, and then whatever this guy returns, it'll pass that into the condition again and loop. So basically, I'm saying, hey, C, Q, no, then do render. Then is the last response you got Q, which is out of, oh, I should have said too. If if the index of this response is out of I handle it explicitly here, but if it's out of range, it'll just add one more element to list. So like if I yeah, sorry. So oh good. Here, if I do this, let me can I run this here? If I say ABC, right? We know this. A will be, or Z, well here we'll get there fast. Um we have 0. Let's get this again here. So this is 1, this is 2, this is 3, but Z is out of scope. So that's why we have the second we're using that here, right? So the result of this is getting past this guy, which is then of course out of range. So we're getting the one more than the length of this list. So if we add like 10 more characters in here, right? Well, this number will go up because the length of this is 20. I'm assuming. Easy. So that's basically it. I think it's not so bad. There's a couple. The reason I want to talk about this was because it was cool to look at, but also just because of some fun things like with the grade up, the the choosing with the index, and then the each or depth or whatever rank. What's it called? I hadn't used it before. Depth, because there's also the equivalent for so this is the equivalent there, but then this one, the cells, has its own matching one too. And because you want to, because the shape of things can be pretty funky, but at the bottom, like if you have like a 10-dimensional table, but you know that every element inside of this is ultimately like a pair, you could just use depth to get to the very bottom. It's not clear to me what the depth and rank differ on, besides the cells. I guess one operates on cells versus elements, exactly like this and this, I imagine. Neat. Well, let me know what you think. It's always fun to hear. I think I'll try to do this again later on when it's a little easier to explain. This is a cool video. Thanks.